Hello, my name is Eli Borngesser, and today I'll be reporting my findings from Physics 2212, Lab 1 on charged tape. So this experiment aims to charge two pieces of tape separately, then observe the interactions between the pieces of tape and other charged objects, or possible charged objects. This experimentation will allow for the demonstration of excess charges present on the tape. After the physical experimentation, the values found will be applied to a computer program to allow for the calculation of the number of charges on each piece of tape and the total overall charge. This experiment looks at multiple physical principles, including electrical charges, net force, gravitation, and electrical field force. And here we have the formula for gravitational force between two objects and electrical force between two charges, and as we can see, they're very similar, and here is just the fundamental principle of charges interaction. So part one of this experiment was the physical part, and the system is the tape being acted on, or the tape in this picture B, and the surroundings are everything else in the universe, including tape A. The two pieces of tape are charged by quickly ripping them off of the table, and this causes charge to move onto the tape, and then these two charged tapes are brought in close to each other to observe the displacement distance. Part two of this experiment was the computational model, and here we have the system again is the tape, and the surroundings are all other forces. Tape surface area was calculated with this part of the code right here, and along with the mass of the tape was calculated here, and then the surface area of the atom was calculated here, and this gives us the total number of atoms in the tape. And then so here we are solving for the overall charge on the tape, and then as stated before, the atoms and electrons using the electrical field formulas. And then Q can be calculated as the charge of a theoretical point charge in the center of the tape, which obviously is not the case, but it's a physical approximation. So the results of part one, the displacement of the stationary tape was 2 centimeters upwards. The tape length of the stationary tape length was 16.5 centimeters, and it was 2 centimeters long, giving us a surface area of 33 centimeters squared and a mass of 3.3 times 10 to the negative fourth kilograms, found by using the density of tape. And then we have the gravitational force of negative 0.003 newtons, and the electrical force is the exact opposite. Part two, it was found by the computer program that the charge on the tape was positive 6.6 times 10 to the negative 10th coulombs, and the number of atoms in the tape was 3.3 times 10 to the 17th, and the number of electrons lost by the tape was 4.12 times 10 to the 9th, so giving us a ratio of electrons lost to atoms present of 8 times 10 to the 7th, which is a high ratio of electrons lost. So the tapes carried an overall positive charge as stated before, and this was proven by the two tapes repelling each other. The tape was attracted to the plastic table in human skin because both carry a formal negative charge often, and it was assumed that the gravitational force was equal to the force of the charge of the tape because after 2 centimeters it no longer went up but also remained in that position. And then possible errors were just measurement errors in the displacement distance because the tape did begin to sink back down as the charges were neutralized. So what if electrons carried a positive charge and protons a negative charge? The pieces of tape would still be repelled, but now the calculated electrical charge would be negative, not positive. And how would the interactions between the tape and other objects be different? This is the same case as the table and the hand discussed earlier. And then why must we interact with the tape as little as possible? Hands have moisture on them, and skin has a slight negative charge, and both of these can cause the tape to depolarize by transporting or balancing the charges. Thank you.